my lonesome self. Okay, so just so you're aware, I did go through every unit in AP Classroom, and I have activated every video. There was like chapter, hold on a second. Hi, Crystal. Hi. No. Yeah, no worries. Yep, bye. Sorry. Okay. So I went through and made sure that every video that they had for review was out there for you guys. Looks like they have a daily review syllabus that you can download. I don't know. So, but anyway, this is all out there for you if you want to go through and watch these videos as well as the ones that I have posted in the Ed Puzzle. In addition to that, I have also gone out to Classroom, and I have started, I put out all the review videos. I believe these are the ones that are in the Ed Puzzle. So these are all out there if you want to be able to go back. And I don't know if the Ed Puzzle allows you to go back and watch it again or not. So I wanted you to have access to these videos as well. And then lastly, I have, and this you will have to watch on your phones. They won't let you watch them on the Chromebooks, but I'm posting these TikTok videos, and they're talking about like different abbreviations and different things on the AP exam and that sort of thing. So if you're not taking the AP exam, don't bother with these videos. But if you are taking the AP exam, they're like 1 or 2 minute little hint things that could be very beneficial to you. Okay. All right. So that kind of gives you an idea of some of the stuff that I've got out there for you. And we're going to get done with the whole notes today. If I don't get done with this in class, then you are going to listen to the video this weekend so that I don't have to give notes anymore, because I'm going to finish them 7th hour during my prep. Okay. So we left off yesterday. We were talking about oxidation reduction reactions. We talked about how we could take these two equations and make them equal to one another, because if A equals B and A equals C, then B equals C. Okay, and we can take out the negatives because they would divide out anyway. So that's what we're going to use down here to solve this guy. Okay. They want us to first balance the redox reaction and calculate E prime, which we can do from this data up here. And then we're going to use those two equations equal to one another to solve for K. All right, so here we go. First of all, we need to identify which one of these is being reduced and which one is being oxidized. So which one of these is being reduced and oxidized? You can either look at this equation here and figure it out, or you can look down here and figure it out using these values. How can I look using these values? Which one's reduced? The more positive. The more positive one. So this is going to be our reduction. This is going to be our oxidation. Okay? And we need to balance this guy. So I'm going to have to take this guy, and I'm going to have to multiply these values by what? 2, because I need to get 2 here. So 2, 2, and 2. All right. So up here in my equation, when I go through with this, then so then I need a 2 here. No, I don't. Libby, bad Libby. Try that again. This one does not get a 2. This one gets a 2. And this one gets a 2. And then I should have this guy balanced, right? Yeah. So now I've got him balanced. I need to figure out my E prime. So remember, E prime equals Ka, right? Cathode minus anode. Which one of these is the cathode? Top one or bottom one? Top, because it's the one that's being reduced, right? So I'm going to take the 0.17 minus a negative 0.50, and that's going to equal a 0.67 volts. So there is my value for E prime. Kinda, sorta, not pretty. Let's try that. There we go. Let's try to draw that line a little straighter and better. Okay, there we go. That's the first part. So they wanted us to balance this guy, and then they wanted us to come up with, so balance this, calculate E prime. Now we need to get K done. All right. So I'm going to have to figure out K here, and I'm going to use my rat link and my NF E prime equals my rat link. Okay. I want to solve for K. So the natural log of K is going to equal NF E prime over RT. Everybody okay with my algebra manipulation here? We just went through a lot of that in pre-AP today, like how you rearrange these equations. And if you like that, physics is your game. Enjoy it, because they do a lot of that flipping around and manipulation in physics. All right. So my natural log of K is going to equal my N value, which is going to be what? 2 moles of electrons right here. That's my N value, my 2. I'm going to multiply that by Faraday's constant, which is 96485. Do you have to memorize that number? No, it's on your cheat sheet formulas. Times the 0.67, we calculated that up above, divided by R. Now we have to decide which R value we're going to use. And when we're in the land of thermochem, it's always going to be the 8.34314. Sorry, pi. And then I need to multiply by the temperature, but this temperature will not work for me. What do I need to do? Yep, so 298. All right. So then that's going to give me the natural log of K will equal 52.2. And so if I take the e to the x, K will end up equaling 4.61 times 10 to the 22nd. What units do I have on K? Equilibrium quotients, reaction quotients, what units do they have?
Polarity.
Trick question, they're unitless. No units on K or Q. Oh, Lippy. Sassy Lippy. There's your K. Okay. All right, moving on. Applications of these things. Lead storage batteries. These are in your cars. Okay, you've got a lead anode. That's the black lead or whatever. That's the metal that's down in there. And then you've got a lead oxide cathode. And then this is your electrolyte, sulfuric acid. So that's why, like car batteries, you have to be careful. Like you don't want them dripping on you or anything because they can, you know, they're acidic. And lead is heavy. That's why your car battery, if you've ever lifted a car battery, you're like, ooh, seriously, it's that heavy? I mean, you look at it and you're like, this is plastic, right? Because it looks like it's plastic on the outside. You lift one up and you're like, holy cow. Well, it's because it's filled with lead. There's a lot of lead in there. There's also these acid versions with zinc anodes. You can have a carbon or graphite cathode. And then you've got a paste in there. And then you've got your alkaline batteries. These typically will have some sort of paste in there that would be like KOH. And that's what their base. And that's why when those things, you know, after time, sometimes they start to eat away at the metal, right? Have you ever seen a battery where it's got like that white pasty stuff on it? Yeah, that's because the metal's gotten eaten away by this strong base. And then nickel cadmium batteries, where you have your anode and cathode, they can be recharged. So like your, a lot of times those are in your phones, cell phones, okay? All right, here we go. Electrolysis. We're going to use electricity. We're going to bring about a chemical change. We're literally, translation literally is split with electricity. So we're going to make that redox reaction happen, but we got to input some energy in it. These are non-spontaneous cells. So if we were to calculate our E prime for this, we would actually have a negative number here. And so that in order to make this run, you've got to insert electricity to make that, to give it that push or that energy to make it happen. So something that's important to note about voltaic cells or galvanic cells that we've been studying, and these electrolytic cells, which are the non-spontaneous ones. These voltaic ones, they happen spontaneously, okay? We set them up, we hook them up, the electrons start to flow. These guys, the electrolytic though, we have to have an electron pump or something, a DC battery, electricity, something's got to be in there that makes that happen. Voltaic or galvanic cells, which we've been studying, are always in two half cells. So you've got a cell over here, you've got a cell over here. So if they show you a picture and you don't have everything's in the same compartment like this, you know automatically that this is an electrolytic cell. Okay. So again, voltaic cell, galvanic cell, they're called the same thing synonymously, voltaic and galvanic, separated into two half cells to generate electricity. Electrolytic is going to happen in a single container. Then remember, an ox and red cat still apply, but the polarity of the electrodes is reversed. So the cathode is now negative and the anode is going to be positive. But the electrons are still going to flow from the anode to the cathode. It's just that they're going to have opposite charges. All right. This, I took out this part for you guys because we're not going to have anything that we have to worry about water for you guys. If there's no water present, which is what you're going to be working with, the cation is reduced, the anion is oxidized. These are going to lose electrons though and go up in charge, and these will gain electrons and go down in charge. All right, so we're not going to worry about the water part. Faraday's law, our last equation of the year. How you feeling about that? I'm overjoyed, personally. All right, here we go. So number of moles of electrons. This has been your N. Okay, this is what I've been counting, like making you count all along is that. You can divide that by moles of the substance, and that's going to give you the moles moles of electrons per moles of material. And then your formula weight is grams per mole. Okay. So let's copy this guy over so I can work with him and write with him, since my computer is being a jerk still. Oops, I had it there. Just need to use it. Okay, so we've got, so they want to know how long a current must be applied to a solution, this is Ag plus, to produce 10.5 grams of silver metal. Okay, so how long, this is going to be time. Okay, and if you look at the equation that was up above there, it said number of coulombs equals IT. I is going to be current, and if you've done any physics with electricity, you're well aware of that I being current. And if you haven't and you're in the land of physics, then this is your introduction, because they like to use that I a lot. Now, on your AP cheat sheet, they don't call this number of coulombs on there. They call this Q. So for you guys, it's Q equals IT, or on the sheet, it's actually I equals Q over T. Yep. So in the sheet, it's I equals Q over T. Either way, you can rearrange it to get this. Okay? All right. The problem with using Q here is that gets confusing when we go back into like I think it's, yeah. So the problem with that is there's another Q, which lowercase q is also heat. So that's why it's nice to think of this in terms of number of coulombs. Eric, wake up. Okay, so that's why this Q gets a little messy here, because you've got a Q up above and then you've got a Q down here, and they're in the same section. And so that gets a little icky to try to multitask with. All right. At any rate, that's what we're looking at, is how long we're working with this. So we're going to be solving for this T value here. So if we do that, we want to do T equals, I want T by itself, so Q over I. Okay, so Q over I is what I got to figure out. All right, I've already got. We've already got the 5.0. They gave us that here. So we've already got that taken care of, but we're missing this guy. And this is what we've got to figure out. Okay? So, here we go. We've got our value here, which is 10.5 grams. We're going to convert that into moles. So we have 107.9 grams in every 1 mole of silver. Okay, now in every 1 mole of this silver, it would be plus, I guess, mole of Ag plus, we are going to have 1 mole of electrons, because it's just giving off 1 mole of electrons. Okay, if this had been a 2, like if this had been calcium and it was a 2 plus, then we would have a 2 here. So it would get off 2 electrons. That makes sense? So you got to be careful with that. It's only a 1-to-1 ratio because it's only giving off 1 electron. Okay, so we're going to do our math here. And when we do our math, we're going to get 0.0973 moles of silver. Electrons. Okay, so I'm going to take that now. I've got that many electrons, and I know from my my sheet here, okay, this is one of my constants on here. It's Faraday's constant, okay, that I have 96,600 or 96,485 coulombs per 1 mole of electrons. I should have had mole of electrons in here. I'm sorry. You squeeze that in. All right, good. Got that all written down, ready to go? All right, so that is going to equal 9,389 coulombs. And that then, you're going to go back and we're going to insert in here because Q is coulombs. So 9,389 is going to give me my time Time in what? What unit?
Second.
How do you know? Exactly. So, hold on. So yes, it's a unit from the blue sheet that had to do with this. So go back and look at the blue sheet. All right, so 1,877. Good Lord. 85 seconds. That's not a 5, that's an S. Idiot. I'm such an idiot. I'm sorry. Okay, so that's seconds. And then if they had asked for minutes, all you'd have to do is divide that by, because our answer key is given to us in minutes. So there's our value in minutes. Good? Make sense? Okay. All right. And our last problem. Last exercise. All right, so you've gotten comfortable, I think, looking up things in the chart, okay? So I'm just going to give you these values. You know how to find them, though, right? Anybody not know where I'm finding these values from? It's the chart at the beginning of this document, or a couple notes ago. Zumdahl was the chart that she got. She got it from a book. There's a publisher named Zumdahl. And that was this chart. Are you dizzy yet? There we go. That was this chart that she got. So that's why she's quoting Zumdahl there for that one. All right. So give the oxidizing ability of these species. So oxidizing ability equals the most likely to be reduced. Because it's going to oxidize something else. If this is reduced, if this is gaining electrons, it's making this thing lose them, right? Because whatever's reduced is gaining the electrons from here. So which one of these is going to be the best oxidizing agent? Which one of these is most likely to be reduced?
The first one, the top one.
Well, how do you know?
It's got the most positive.
Right, yeah. Which one is the most positive value is going to be the one that you're going to reduce. So this one is going to be make things reduce better, and then this one, and then this one. So it's already in order of it, okay? So the most positive value equals the best oxidizing ability. L-I-T-Y. Ooh, it's not pretty handwriting, but it gets the point across. All right, now I need to go down here. All right, so applications of these things. So there are applications when they mine metals out of the ground. Okay, they don't come out and just like, oh, this is a pretty shiny piece of aluminum. Okay, it comes mined with a whole bunch of other stuff, and they have to get that aluminum by itself. So this Hall-Héroult process is producing this aluminum where they take that, they have these graphite rods in here, and They're going to have this molten like aluminum oxide and silver aluminum fluoride and all of this stuff in here. And then this will draw that material, and then the molten aluminum is able to go out. And then they have the same thing here for creating chlorine. So they'll take molten sodium chloride in here and calcium chloride that they mine or that they get out of like salt flats from like Salt Lake City area. Okay, they heat that up and they make that molten, and then they have these cathodes in here, and that forces the chlorine gas up. Electroplating. So anything that you get, any of your gold, any of your chrome on your bumpers, anything like that, they would have used electroplating to make that happen. Your car battery. Okay, your car battery, you can only use your car battery for so long. That's why if you leave the radio on or you leave it on but not actually the engine running, it'll drain your battery down. It used to be a real bad thing back when I was young because you didn't have any warning that you left your lights on, and you didn't have it, your lights wouldn't turn themselves off when you turned the car off after so long. Okay, so you had to manually turn your lights off. So like my husband, he had an old Chrysler Horizon, okay, and he would forget to turn his lights off. So anytime he turned his lights on, he would stick something, a little thing that would hang on his light switch so that it would make him, force him when he turned the car off to make sure they turn the lights off. But you would see people, you know, getting their cars jumped all the time because they'd forget to turn the lights off. You would have people paging people over the intercom all the time because they would, you know, so-and-so left their lights on. You don't really get that much anymore because the cars pretty much turn them off all the time now. But it used to not be that way. But that battery will only last so long to power lights and that sort of thing. And you have something in your call called an alternator. And that alternator essentially brings that charge back to your battery. And over time, your battery will eventually diminish to the point where it can't recharge using the alternator. And you got to get a new battery. Like at my truck, probably a year or so ago, I had to get a new battery for it. Okay, but I also had 75,000 miles on it, so that was pretty good for a car battery. That was a pretty decent life. But they're expensive. They're like $200-300. Like they're not cheap. But you also look at what's in it. Like, you know, they have to seal those things up tight so the sulfuric acid doesn't get out. I mean, that lead is not cheap. The shipping on those things, because the thing is heavy, the shipping on them is expensive. So you've got to take all of that into consideration. And then, you know, we're constantly trying to not go this spontaneous route. So you've got expense that's trying to like keep corrosion from happening. But remember, corrosion is a spontaneous process. So you're just essentially trying to fight the inevitable. And if you look at my truck, you know, it's 10 years old now. It's starting to show some of the signs of this corrosion. So, you know, a lot of money in the country goes to this. Like steel, for example, when you think about like steel and buildings and bridges and infrastructure like that, they have to replace that every so often because it loses this structural integrity. Ships that they have, they talk about, do we talk about that in here at some point? Yeah, so here's like the rusting and that sort of thing. And then they do have ships, yeah, here, when they're talking down here. So ship hulls here, they will put bars of titanium on them. Since it's in salt water, the titanium acts as an anode. The titanium's oxidized instead of the ship hull. And then every so often they have to replace those titanium rods, but that is so much cheaper than replacing the ship hulls. So there's, you know, there's practical applications of this that come about. So that, my dear children, sums it up. We are done. I will be posting your progress check online for this unit. So I expect that to be done sometime next week. I'm not going to give you a test on this because we need to get started with our review. For those of you not taking the AP exam, you're welcome to sit in on the review, or if you want to work on your videos in the back with your headphones, you can do that. The rest of you that are signed on with me for another 2.5, 3 weeks, yeah, we're going to start cramming for that test, and you're going to tune in to me on the days that you're off and catch up on those review videos that I'm reviewing with everybody else, okay? You're also going to come in and you're going to tell me questions that you have that you might need answered, weak points that you're at that you want me to focus on. So you need to let me know what those are so that I can spend a significant amount of time on that. Yeah.
I got one.
Yeah.
Do you review how to do like the decimal, like the easy decimal math?
Oh, like math, like mental math?
Yeah.
Okay, so mental math, okay. Any other? And then we had talked, at least in the other group, I don't know about in this group, about doing AP t-shirts for taking the exam. So if you guys want to design one, I can cut out the stuff on the Cricut and I can iron it on for you. I just need a t-shirt, and then I need you guys to come up with a design. So. Yay! This is like Freedom Day for me, guys. Not as much as May 7th. Once we hit May 7th, yeah.
Are we just going to be doing some makeup experiments in the back?
Sure. We will figure all of that out when the time comes.
What?
The team that you can do well within one class.
Yeah, that sounds good. How many injuries can we get?
No.